Dear students, myself I am Mamta Devi AP, Assistant Professor of Chemistry. In this video, I am going to explain sessions 50 and 51 of Spectrophotometry and Photochemistry. Contents of this video are detectors, thermopile and photoelectric cell, determination of absorbed intensity, actinometer, chemical actinometer, example uranyl oxalate actinometer. Detectors. Detectors are generally used for the measurement of transmitted light, example thermopile and photoelectric cell. Thermopile. A thermopile is an electronic device that converts thermal energy into electrical energy. Thermopiles are used to provide an output in response to temperature as part of a temperature measuring device. Thermocouple. It is a thermoelectric device consisting of two wires of different metals which produces temperature gradient to generate current. Thermopile. It is a set of thermocouples. Rods of two different metals, example silver and bismuth, are joined alternatively as shown in figure. One set of junction is soldered to metal strip and blackened with platinum or lamp black. Other set of junction is protected completely from radiations by placing the system in a box. Radiations falling on the blackened metal strip are almost completely absorbed by it. As a result, this set of junction becomes hot. The temperature difference between the hot end and the cold end produces the current, which can be measured by connecting a milliammeter or galvanometer to the thermopile. By calibrating thermopile with radiations of known intensity, the intensity of the desired radiation can be measured. Photoelectric cell. A photoelectric cell can be conveniently used for measuring intensity of light. The light striking the active metal electrode like cesium, sodium or potassium causes the emission of electrons. A current flows through the circuit which can be measured with an ammeter. The current produced is proportional to the intensity of the light. Determination of absorbed intensity, that is IA. The light beam from a suitable source like tungsten filament or mercury vapor lamp is made to pass through a condensing lens where a parallel beam is produced and then pass through a filter or monochromator which gives light of single wavelength. The monochromatic light is made to pass through cell made up of glass or quartz and then to the detector which measures the intensity of the transmitted radiation, that is, a part of the light not absorbed. Detector is usually a thermopile or an actinometer. The difference between the intensity of incident and that of the transmitted light gives the intensity of the absorbed light. That is, IA is equal to I naught minus IT, where IA is intensity of absorbed light, I naught is the intensity of the incident light, and I is the intensity of the transmitted light. Actinometer. It is a device used to measure the intensity of the radiation. It was invented by John Herschel in 1825. Chemical actinometer. A chemical actinometer is a device which uses a chemical reaction whose rate can be determined easily. Example for chemical actinometer are uranyl oxalate actinometer and potassium iodide actinometer. Uranyl oxalate actinometer. The principle of this actinometer is a definite amount of the radiation absorbed brings about a definite amount of the chemical reaction. This actinometer has a range of 208 to 426 nanometer with an average quantum yield of about 0.5. Uranyl oxalate actinometer consists of 0.05 molar oxalic acid and 0.01 molar uranyl sulfate in water. Uranyl 2 plus ion acts as photosensitizer. This reaction has a quantum yield of about 0.5 to 0.6. Solution required. 0.42478 gram of uranyl sulfate and 0.67262 gram of disodium oxalate in 0.02 normal sulfuric acid and diluted with distilled water to 1 liter. Overall reaction: when it is exposed to light, oxalic acid is decomposed to carbon dioxide, carbon monoxide and water. In the first step, uranyl 2 plus ions absorbing light, it produces an activated molecule of uranyl 2 plus ion. In the second step, this activated molecule of uranyl 2 plus ion reacts with oxalic acid to give carbon dioxide, carbon monoxide, water and regenerating uranyl 2 plus ion. Amount of extent of decomposition of oxalic acid before and after exposure to radiation is determined by titration with potassium permanganate solution. The amount of oxalic acid decomposed is a measure of light absorbed. Extent of decomposition is a measure of intensity of radiation absorbed. If you want to refer more about these topics, study Principle of Physical Chemistry by B.S. Bal, G.T. Tuli, Arun Bal, Principles of Physical Chemistry by Puri Sharma Patania, Physical Chemistry by P.W. Atkins, Physical Chemistry by W.J. Morey. Thank you.